Hello, my name is Brandon Montford. I am a senior at Concordia University of Chicago, and I'm currently studying computer science. And I want to welcome you to my YouTube channel. So today we're going to be talking about software and why it matters. So at its core, software is simply just a set of instructions that tells the hardware, the physical components of a computer, what to do. So if hardware is the body, then software is like the mind. It's the invisible logic that turns like raw electricity into communication, creativity, automation, and intelligence. From operating systems like Windows and Linux to mobile apps and artificial intelligence, software shapes and is integrated into how we live, learn, and connect. So to dive into the history a little bit, in the 1940s and 50s, people programmed with punch cards, switches, and raw machine code. It was slow, it was full of errors, and it was tied to one specific machine. That meant if the hardware changed, then the code usually had to be rewritten from scratch. And then progress came in the 1950s through 70s, where new higher level languages like Fortran and COBOL showed up. They let people write more readable code. It was using words instead of just ones and zeros. That opened the door for large corporations like banks, governments, and research labs to start using software seriously. And then in the 80s to 90s, personal computers went mainstream. Operating systems like Windows and Mac OS made computers easier to use, and then software started showing up everywhere. It started showing up in spreadsheets, word processors, and databases that powered entire companies. And then from 2000s on, the internet changed everything. Because now you have open source projects, we have cloud computing, and AI made software global. Now it runs communication networks, finance systems, hospitals, and transportation. So basically, if it's connected or automated, software is behind it. Now to relate to large scale projects. When software scales to large systems, it stops being about the individual features, it starts being about the architecture, the efficiency, and the coordination. At that level, software enables automation, handling complex tasks faster and more accurately than we could before. It's built for scalability, growing from few users to millions without breaking. Abstraction is key. It hides the complexity under the clean interfaces, and it allows teams to build and extend systems without starting from scratch every single time. Large-scale systems also depend on collaboration because teams across the world can use the same code base using shared tools, version control, and continuous integration pipelines. Then there's infrastructure. Software runs critical in systems like healthcare, finance, transportation, and even space exploration. It helps keep real-time systems online, coordinating communication with data and minimal delay. And then with data and AI, software can now process massive amounts of information, finding patterns and making predictions that guide decision-making processes. So basically, in short, software at a large scale it's not just about writing code, it's about designing systems that evolve, adapt, and they stay reliable as the world continues to depend on them. Thank you.